In this video, we're going to learn how to do some matrix operations. We've used matrices for solving system of equations, but they can also be used in other types of business applications. We're also going to learn how to use some different notation to identify individual elements of a matrix, add and subtract matrices, and multiply a matrix by a scalar. So a scalar probably is a new word to you. It just means a number. Let's first look at what we mean by matrix operations. So if we're trying to add or subtract two matrices, what we're going to do is we're going to add or subtract the corresponding elements of the matrix. So for instance, this element 3 here in matrix A is in the same spot as that -4. So when we're adding two matrices, we're going to add those corresponding elements. So we're going to have 3 plus -4. The -1 is in the same spot as the 5, so we're going to have -1 plus 5. The 2 is in the same spot as the 3, so we're going to have 2 plus 3. And the 5 is in the same spot as the 0, so we're going to have 5 plus 0. Our answer is going to end up being -1, 4, 5, 5. Now notice that matrix A is a 2 by 2 matrix and matrix B is a 2 by 2 matrix. If we're trying to add matrices by adding the corresponding elements, our two matrices really need to be the same size in order to do addition. If we had another matrix that was a different size, maybe I had a matrix C that was a 2 by 3 matrix, I would not be able to do A plus C. That would not be possible. Okay, so the next thing we're going to do is multiply by a scalar. And remember, a scalar is just a number, and our scalar in this case is the number 3. So if we're trying to take 3 times matrix A, what we're going to do is we're going to multiply 3 times every element of matrix A. So we're going to have 3 times 3, 3 times -1, 3 times 2, and 3 times 5. So our final matrix is going to end up being 9, -3, 6, 15. One last operation that is handy is called the transpose. And now notice that for the transpose, we put a little t up in the exponent. We don't actually say c to the t, we just say c transpose. This type of operation with our matrices, what it does is it swaps the rows and the columns. So this is row 1. This is going to turn into column 1. It's going to go here in column 1. So I'm going to have a 3, 0, 5. This is our row 2. It's going to go to column 2. So we're going to have -1, 4, 2. One other thing to notice, that my matrix C was a 2 by 3 matrix. It had 2 rows, 3 columns. My C transpose is a 3 by 2 matrix. So 3 rows, 2 columns. So when we do the transpose, that swaps the size numbers. Let's look at an example of how we might use this in a business type scenario. So we're told that the sales of video systems in October at 3 different stores, Northgate, Linwood, and Everett, were 80 PS4s, 60 Xboxes, and 20 Nintendo Switches. The Linwood store we had 55, 45, 25. And at the Everett store we had 75, 60, and 15. So just looking at this particular paragraph, we have this particular paragraph. This is the same types of information about November. This information was all about October. What they're asking us to do in this problem is to write the sales data for October and then November, where the columns are the store locations and the rows are the video game systems. So if we think about our matrix C, which is our October data, our columns are our 3 different locations. So we're going to have Northgate, Linwood, and Everett columns. And then our rows are our game systems. So we've got PS4, we've got Xbox, and we have that Nintendo Switch. So what we're going to do is we're going to take all this data and put it in the matrix to help organize it. So Northgate, we have 80 PS4s, 60 Xboxes, and 20 Nintendo Switches. At the Linwood store, we had 55 PS4s, 40 Xboxes, and 25 Nintendo Switches. And then at the Everett store, we had 75 PS4s, 60 Xboxes, and 15 Nintendo Switches. There's our sales data in a matrix form for October. Pause the video and you write the November matrix. Do you get something that looks like that? So another thing that can be handy is to be able to identify a specific element of your matrix. Typically, when we're talking about matrix names, we always use capital letters, capital C, and then when we're talking about the corresponding elements of that matrix, we use lowercase letters. So if we wanted to find the element C sub 32, the 3 represents our row number and the 2 represents our column number. So we're looking for the element in row 3, column 2. So that would be this element right here. So this would be 25. And what they're asking us to do is to interpret that. So we need to say what that means. So remember, our columns were Northgate, Linwood, and Everett, and our rows were PS4, Xbox, and Nintendo Switch. This particular 25 tells us in October there were 25 Nintendo Switch systems sold at the Linwood store. Pause the video and you do the same problem, but this time you're looking to identify and interpret the value of n sub 13. Did you get n sub 13 was 70? And the meaning is in November there were 70 PS4s sold at the Everett store. So the next thing we're supposed to do is find the total sales for October and November. So when we're trying to find the total sales, this is a somewhat easy one. You guys probably can just immediately know how to do this, but sometimes it's not so obvious. So let's see how we could figure this out. So oftentimes it's helpful to figure this out for a specific quantity instead of figuring out for the whole thing. So remember that this last column represents Everett, and let's say we're looking at the first row. If we wanted to know how many total sales of PS4s there were at the Everett store, we would take that 75 from October and add to that the 70 from November. And so our total sales of PS4s at Everett would be 145. So what we did there was we added this element and this element. So in order to find the total sales overall, we could take matrix C and add matrix N. When we do that, we already did this last column. We got 145. 80 plus 65, also 145. 55 plus 50 is 105. 60 plus 50 is 110. 40 plus 45 is 85. 60 plus 50 is 110. 20 plus 25 is 45. 25 plus 20, also 45. 15 plus 20 is 35. In the next question, they say that the sales are predicted to be 50% more than the sales in November. And we're supposed to use matrix operations to find the expected total sales for December. So let's do that same sort of thing. Let's look at Everett, and then let's look at the PS4s. If our sales in December are supposed to be 50% more, well, I could take our sales in November and add on to that 50% more. 50% of that 70 is what I'm adding on. So if I were doing that numerically, if I was trying to calculate that, I would take 0.5 times 70, which we could sort of combine instead of actually calculating it as this way. I could think of this as 1 times 70 plus 0.5 times 70, so that's 1.5 times 70. So this sort of gives us a formula for how we could calculate this for the total matrix. So basically I need to take and multiply my numbers by 1.5. That operation is a scalar multiplication. So I'm taking 1.5 times my n. And when you do this, you should get the following matrix. So this is our matrix, that's 1.5 times our n. Now one thing to notice here is, like, if we look at that, that represents, so that's Linwood and Xbox. There's no way we can sell 67.5 Xboxes, but it does give us an estimate. Okay, we'll probably have 67 or 68 Xboxes. In this next question, it tells us the price for each game system. So PS4 sells for $300, Xbox sells for $300, Nintendo Switch sells for $250, and what we're supposed to do is find the revenue for the Linwood store. So remember, Linwood was my second column. This was my PS4, this is my Xbox, this is my Nintendo Switch. So my revenue for that month for the Linwood store is going to be, so I take my PS4, so those cost $300, and I sell 55 of them. And then I add on to that my Xboxes, so those also sell for $300, and I've sold 40 of them. And then, let's see, the Nintendo Switches, those cost $250, and we have sold 25 of them. So when I add all these numbers together, I end up with 34,750. Now, this wasn't a matrix operation, but it was a calculation that we did with matrices. We're going to learn in the next section how this really is a matrix operation, but we haven't quite defined it yet. Okay, last problem. It says when you present the sales data to your manager, she asks that you make it so that the columns and rows are swapped. What matrix operation will make this happen? So remember, if we want to swap the rows and columns, if I want to take that row and make it a column, that is a transpose operation. So if I were doing n transpose, this was a 3 by 3 matrix, so this is still going to be a 3 by 3 matrix, but this purple row here is going to become the first column. So this row 1 is going to become column 1. Row 2 here is going to become column 2. And row 3 is going to become column 3. And now this row, instead of representing PS4s, this row is our Northgate row. This is our Linwood row, and this is our Everett row. And our columns are our different game systems. So this is our PS4 game system, this is our Xbox game system, and this is our Nintendo Switch game system. So we're going to do one more example that has a couple of little tweaks to these problems. First of all, notice that I'm giving you matrices that are different sizes. So all the matrices so far we've done, I always give you two matrices of the same size. And also notice that in this matrix A, I've got variables. Okay, so the first thing we're asked to do is find 4 times matrix A. So this is scalar multiplication. So I'm just going to take the number 4 and multiply every single element of my matrix by 4. So here I have x, I'm going to have 4 times x. Here I have 2. I'm going to have 4 times 2, which is 8. Here I have a 3. 4 times 3 is 12. Here I have a -1. 4 times -1 is -4. Here I have a y. 4 times y is 4y. Here I have 0. 4 times 0 is 0. Part B, it says find A minus B transpose. Okay, first thing, we don't know what B transpose is, so let's figure that out. So remember, B transpose, I'm going to take my rows and my columns and I'm going to switch them. Let's see, let's take column 1 and we're going to make that be our row 1. So that's going to be 4, 1, 2. And column 2, that's going to be our row 2. So I'm going to have 3, -5, -2. One thing to notice here is that if I were trying to add or subtract matrices A and B, like if I were trying to do A minus B, I wouldn't be able to do that because this is a 2 by 3 matrix and this is a 3 by 2 matrix. So they're not the same size. I can't do that. However, matrix B transpose, this has 2 rows and 3 columns. So matrix A and matrix B transpose are the same size. So I will be able to do that row operation, that matrix operation. So I'm doing A. So A is the matrix X, 2, 3, -1, Y, 0. And I'm subtracting B transpose. So B transpose is 4, 1, 2, 3, -5, -2. So I just want to be careful about that negative because I'm going to have to subtract a negative number a few times here. So here I'm going to have x minus 4. That was easy, x minus 4. Here I'm going to have 2 minus 1. 2 minus 1 is 1. Here I'm going to have 3 minus 2. 3 minus 2 is also 1. Next element, I'm going to have -1 minus 3. -1 minus 3, that's -4. Here I'm going to have y minus -5. So that's going to be y plus 5. And the last one, I have 0 minus -2. So that's 0 plus 2, or 2. Okay, last problem, this problem right here. We want to do 4a plus b. So my matrix 4a, that is right there. And my matrix B, that is that matrix right there. In order to add two matrices, they have to be the same size. 4a is this 2 by 3 matrix. B is this 3 by 2 matrix. Those are not the same size. I cannot add these two matrices. This is not possible. I hope you found this video helpful.